Good evening. Today we have an amazing case study. Today I have Peter with me, and Peter implemented a micro front-end based system for the Dutch railways. He used module federation, and currently he is migrating it over to native federation to use the new ES build builder that ships with Angular. Hi, Peter.
Hi, I'm glad that I can give a talk about it. I'm very keen to do this.
Yeah, I'm glad you are here. We are already talked about it a bit, and it's really a cool case study, and I'm really happy that we can show this to our audience.
Yeah. I'm also happy about it. I want to show you an app. It's called Spoor Viewer. It is made for the Dutch railway company, you say already. And it is the company is of course responsible for the maintenance and the renewal and expansion and safety of the Dutch railway network. And I want to show you one application which is called Spoor Viewer or Track Viewer, you can say in English, and where users mainly work in the rail sector. And the Spoor Viewer, they can see where trains are and what the delay is and from which track they will disappear. And can I show you some screen, Hero? Here.
Yeah, cool. Let's
here is a little architecture about the Spoor Viewer or Track Viewer, we call it. So the Spoor Viewer is the host or the shell of the application, and which is responsible for viewing our which micro frontend is displayed on the screen, and also handles authentication and also communication. And is also I also implement the native module federation. The approximate viewer, that is you can load it multiple times. You see, you can also load the plan viewer and BAM viewer multiple times on the screen, and those are micro front ends. And the approximate viewer follows the train positions. I will show you. And the current, you can also see the current infrastructure conditions, such as route settings and occupancy. The plan viewer is for showing the plan data, and the baanvak is for shows the position of the trains on the track. You can say which train is in front of you or behind you. So you can also load them multiple times. So this is a little bit in a nutshell the application. I can also show you a little bit more about the Clever here. This is the working application. Here, this is the Spoor Viewer itself, and this is the native federation implementation, where we can load some apps. Here you see Approximate Viewer, Plan Viewer, baanvak. Approximate Viewer is a very important one, so everybody can see. So, and Plan Viewer, I can load it here. Again, you can load it multiple times. And again, a Approximate Viewer and a baanvak. Right? I can say apply it. I can choose here a approximate. They call it a region in Holland. So Utrecht or Amsterdam, you can choose. I choose Utrecht, the south part of it. Oh, well, at the moment, communication is down. I see a little bit. Okay, let's do it again. I think it is not so. Let's do it with one part for the. Let's save it. There's also a way of communication to save something from the micro frontend to the host, and it show an. Here,
this is the cool view.
Train is driving here from on this stretch, and you can also say I want to find a train on this screen, for example, or in Holland, I want to follow a train with the number 2257. So it loads the approximate or the region in Holland where we can follow the train. You see.
Wow,
Also
wow.
do it. You can also, if you're make it, play with it and also move it around and also save it again.
Mm-hmm.
So here I save some data from the micro front end to the shell.
Mm-hmm.
So this is I also want to show you how I do that, and I can also load data from the shell to the micro front ends when there is new
Mm-hmm.
configuration, for example. Here I have another tab where I show another one or this one,
Mm-hmm.
and here
Oh,
you see
yes.
the plan viewer where you see the plan data.
Mm-hmm.
These are all the trains on a certain time, and this is the baanvak. You see where this is a train, and you see here the trains behind and the trains in front of him. And you see
Mm-hmm.
when it is red, it has a delay, and this one is too fast,
Oh, yeah. Oh,
so
that's also nice.
so they can follow each other.
I did not know that a train can be too fast. This does not exist in my life or in
Yeah,
my world.
right. According to the planning. So,
Uh-huh.
um, and
I
mainly
see.
people are working on the tracks. We're working on the tracks and also repairing tracks. They use mainly this applaudissement viewer with all those tracks and trains
Mm-hmm.
to follow, and you can also say what you want to show. Crossings, you say it, train numbers, or no, you don't want to show it, or you can say I want to show the bridges or not, or you can also apply it. So you see here more data now. You can also zoom in and also save it. And this data is morely used on people who are sitting behind the desk.
Mm-hmm.
And yeah, okay, we use micro front ends. Is to increase development speed, and also for micro front ends we can develop and deploy independently. This is a very important one for us, and speeding up also our performance of our application because a year ago we had this type of application. I will show you here
Mm-hmm.
the slide. That was a year ago with web components, and you see that we are loading. We are loading here our viewers again, but also Angular we use for our application.
Mm-hmm.
One language we use here, and we are loading Angular multiple times for every time we place a viewer on our screen. So that is very slow, the application. So,
Mm-hmm.
and also other shared libraries also loaded multiple times. Oh, here also 3 times, and there also. This is not what
Mm-hmm.
we want. So we stepped over to Sport Viewer with native module federation,
Mm-hmm.
and you see that we can now load Angular once, is loaded once with native. Also with Webpack module federation, you have that advantage, and that speeds up the application 60%. It is or 70%. It is better. The performance is better than the traditional web component
Oh,
solution
wow.
we had.
Wow.
So that is
70% in terms of the startup time or in terms of memory footprint?
it's more startup time and also
Uh-huh.
with playing with all those and loading all those screens. Yeah,
Oh, wow.
yeah,
That's an impressive number.
yeah. And also, in future, also we want to attach also application which is created with React, for example, or Vue. So okay, and that is also a little bit it's also possible with this native model federation. Also, this is very good.
Mhm, mhm.
Uh, what I want to show more about it. Um, how does the shell application, how does it know, how does it have the knowledge of the we said it, how does it know about these micro front ends? This shell application knows about its private micro front end
Yeah, yeah, yeah.
via
That's a
these
good point.
via
I guess
these
you have some service telling us about where to find this or that micro front end. Is that right?
Yeah. So it is because we have we can expose our application as a URL. You see here a separate BAVAC viewer, you see?
Mm-hmm.
And it is a separate URL. You see here BAVAC.
Mm-hmm.
It is this one I load here in the application, in this screen. It's this one. Oh, no, it's this
Uh-huh.
one, this last one. And you can also here play with it. So it's also good that you can develop here separately.
That's good. Yeah, that's
That's good.
important.
And also the plant viewer here. This is the name. We can also play with it and develop with it separately. That's very
Mm-hmm.
important because every team can own its own application, and then when you're ready, you can embed it in your in this application.
Mm-hmm.
Yeah, appartement viewer. You can go to Utrecht north part. Now there's a very quite big one. So
Mm-hmm.
okay, then you can play with it, of course. Yeah, show you everything or nothing. So
Uh-huh. Uh-huh.
what is also good to know is that the host application knows about these microfrontends via these URLs. And what
Mm-hmm.
also important is that we use a remote interface. This is where the shell application works with. Uh,
Mm-hmm.
it works with the remote enter file, and this file provide information about the libraries that a remote application is willing to share with the shell application, with the host application. So
Mm-hmm.
here the name of the BAVAC, BV, and here I see which libraries this application is willing to share with the shell application. So all Angular applications, you see some RxJS libraries, and also the same with Plan Viewer, also the remote entry file JSON. They've also, there's also a JSON file you want to share, and the implements you have the same remote entry JSON
Mm-hmm.
file. So this is how the shell has knowledge about the micro frontends. What can I say more about it?
And I think this remote entry is already produced by Native Federation. But then the second question is, how does the shell know where to find those remote entry JSON files? Is
Yeah,
there some kind of registry, or are they somehow coded into the shell?
yeah. I have here a dummy application because I'm not allowed to show the real application
Mm-hmm, mm-hmm,
uh, from the Dutch railway company. So I show you, it's really simple, very, very simple application where the setup is the same, but it's so simple that it is not really okay. It is simple enough, and this you can also see that it is no rocket science to implement all the stuff.
mm-hmm,
Firstly, we define in our shell application. I've here created a monorepo with two applications, the shell and micro frontend one. That's all.
mm-hmm,
Let's start with the shell or the host, and the host we define in the manifest file in the assets. I have a manifest file for the local JSON manifest file, and I define here the URLs
mm-hmm,
I showed you just. And also for acceptance and production, we have the same file.
mm-hmm,
I also spin up during bootstrapping of application. That's very important. I can read this manifest file. I do this as follows. During the bootstrap of application, this file is started up, and it loads, it imports the native federation.
mm-hmm,
Here for a switch statement, I do a lookup for the host name, where the host name is running, or local host, or it is running on production. Now in this situation, I'm running on local host.
mm-hmm.
So he says, okay, you can find the JSON file here.
Oh yeah.
Production, you can say if production, I add the location of the production. Okay, I add the production directory to the location, so I can find the right manifest file.
Okay, and so we know where to find the micro frontends. Okay,
Yeah.
cool.
Yeah.
Cool.
So this is, for example, the production URL. Let's see what I can also show you a little bit about the very simple application. It's not the same as the Spore Viewer, because Spore Viewer works also with WebSockets. I want to show you also. But let's start here with this one. I have here the micro frontend one, and this is also this is sort of, you see the dots here. This is the micro frontend. You can add tasks here. There's only for show how the communication works in this application. You see the emplacements viewer, and also I have a shell application where I can also load my micro frontend inside of it. You see the dots, and I can add task. Train 1 is blocked. So, and I here I add it here in the task list. So you see an example how I communicate from the micro frontend between this micro frontend to the host application. So, and on the train 3 is running, or doesn't matter what I do. And also track 5 of 8 is blocked again. So this task list only, so you can see that I communicate from my microfrontend to the shell, but I also communicate from the shell to the microfrontend via this message. Amount of tasks exceeds 2. There's only a very simple application to show you, and I want to also show you the code I made. You see that this one has also this one has also a remote entry file. So here you see that this one is also have a name and is also sharing these kind of libraries. Let's go to code. How do I create this? Firstly, I define where do I define where I share my my libraries. Let's go in the shell and also in the microfrontend one. I use a federation config file. The microfrontend one, I have defined it as follows. In this file, I give a name, and I also say which component I want to share. I want to expose to my shell application, and also here defined as the very important part, which libraries I want to share. So for simple application, this is it's one-liner. I share all. That means I share everything here inside of this part of my package.json file. I share it with my shell application, these shared libraries. But I can also skip some. Here in this section, I add the packages I don't need to need at runtime. So this micro frontend is also loaded at runtime. That's also important to know. And so I share all those packages in package.json except this one at runtime. And at the shell application, I have also this same file. I expose nothing, of course. It's only it receives the information of the micro frontend via the manifest file, the URL. But it also shares the same libraries, share all, and also shares the same package.json. Where is it? Okay, I showed you already. This is those are the packages I don't need at runtime. That is one. I showed you already this application, simple application. Let's show it again. Here I add a task. I show it here. This list that you see here, I have here implemented here a list here, a for loop through the tasks. And I have also here a button, load emplacement. There's this button where I can load it. And what does this load emplacement do? I show you here an example of how I load it. And also I set up a I'll show you the code how I communicate with the micro front end in a programmatic way. So firstly, I clear here a view container ref. What is that? Container ref refers to the remote component container, which I define here.
Okay, our placeholder.
Sorry?
It's a kind of placeholder, isn't it? It's where you load the micro front end into.
Yeah, this the part where we load our micro front ends in, our tiles, our micro front ends. And that's when we have a ref, I can load my remote module. This is a method of module federation, native module federation. Here I can load the micro front end with this name, this component. I load it here. I go to this method. Via the view container ref, I create a reference to the component of the micro front end, the app component. And then I grab the instance of it. And via the instance, I can set up a communication with the micro front end. So on app changed, I can subscribe to it. I can subscribe to data which comes into which is sent to the shell application, to the host application. And these are the tasks, of course, I want to show in the task list. And also can also send a message back or data back to the micro front end. I do that here. When the task exceeds 2, I send a message back via this message. So it's not so very complex. So you have to recognize this one on app state changed and message host to host. Or are these for fields? Or when we go to the app component of the micro front end, you see there's here in the app component of the micro front end that I have defined here input and output properties with the same names. This is for the input to show the message. Too. And here I define the output event to send my added tasks. So where do I do that? Here, the add to task card, add task to card. Here I define a simple task. And here I hit my task to the shell. So this is all you have to do with when you want to have a communication from the micro front end to the shell application. This is what we want, because we want a loose coupling communication between micro front end and shell. You can also, of course, set up application in a global way. I've created it also in this application. For example, mode. This is global communication, but the disadvantage is that the micro front ends are then tightly coupled together via the global state management. You can say global. Okay, this is a little bit, but I also created it for this example. Okay, this is what we want: loosely coupled application communication.
Sending messages around, and perhaps one of the micro front ends will pick up the messages, or perhaps several of them, and then they will act accordingly.
What I want to show more now is also I want to show that this application is also more complex, of course, than my simple application. We go to the network. Oh, let's reload it again. Right. You see that I have here some WebSocket data. And I can show you that I have here application instellingen, or the settings of this screen of this tab. Or do we have more? Okay, a lot of information, connection data of train positions, delays. I see here, okay, etc. Open another tab or another tab. You see more WebSockets are open. So we have real-time data. This is not what I created in my simple app, but this is a very complex app. But I don't want, and then I'm not allowed to show the real code.
So does each and every micro frontend open its own WebSocket connection, or is it done through the shell, its own?
Yeah, right. Yeah, you're right. Yeah.
Cool.
So that is cool. Yeah, it's also loosely coupled. So you can. We have made here a screen where you can see if the WebSockets. The information is still flowing well, going well. These are the WebSocket information. It is about the tracks, and this is about the train positions, TPS, and etc. Yeah.
Cool. Cool.
Yeah, and when you change something, you see that there is here a star, and we can save it. And this is the communication I showed you already. This is how the communication goes also. The same way as I showed you from the micro frontend to the shell, which saves the data in the backend, we can say. Yeah.
Cool. Yeah, that's a really nice case study of, I would call it critical, perhaps even mission critical application that helps all the operators out there. One thing that is really nice here is that we can have the same micro frontend multiple times because of this, let's call it dashboard character.
Yeah.
And that's why we cannot directly use the router. But as shown before, we have to do lazy loading by ourselves by putting the micro frontends into a placeholder, into a view container.
Yeah.
Wow, really impressive.
We're very happy about it. It is that the performance is very well. Our architectural goals were independent deployment, independent teams. We can work independently on these applications. We have showed you already, and also the independent deploying it, because every microfront has its own CI/CD pipeline, and we also every microfront has its own unit tests and also integration tests. We test it with Cypress, and incremental upgrades are also quite easily then. And increased performance was also our architectural goal we met. With module federation, we can share code at runtime, and Angular is loaded once. I showed you already on the slide. So this is very good, and that speeds up the performance 60%. And the scalability by combining microfrontends with module federation, we can create a you see in it, create a distributed architecture where modules can be loaded on demand. So this is of course this is a distributed way for your URL. So I think it's a little bit what I want to show you until now.
Yeah, cool. So now we have seen a lot of good stuff here, and it's really an amazing case study. I think it already runs out there with module federation, and this is now the next step, the next version that will use native federation. So besides all the advantages we have discussed, were there any challenges you faced?
There were quite not so much, but there were a lot of challenges, of course, about we want to be future proof. A little bit difficult sometimes. This is what the performance issues we have. So this is one thing. So we have to. There was a little bit uncertain about can we solve this with this application, with this tool. But I've seen a lot of talks and also read about module federation. I saw that Angular and all those shared libraries are loaded once. So that is okay, and that also is true. And it is the performance is very good. So there was one challenge, of course, a little bit uncertain in the beginning, and version conflicts sometimes.
Mhm. Oh yeah, good point.
There's also, we try to have all those micro frontends. We try that it is have the same version, of course, but
Mm.
sometimes it is a little bit conflicting.
Yeah.
And
I think it's the
but
easiest approach to make sure you have the same versions everywhere.
yeah,
Otherwise, if you need to mix and match versions, you can do it, but this involves some abstractions of those versions, like putting them into web components or stuff like this. And of course, if you don't need this, then the single version strategy is far easier.
yeah, yeah. And create an app that feels like a cohesive wall is always a cohesive world to the user is also always a challenge, you can say.
Mhm.
We use now UI component library. I can
Mhm.
show it because I'm not allowed to it. And we are stepping over to Storybook, and we use style guides and UX standards, shared libraries, which we can code. Can code it once.
Mhm.
Communication and collaboration between our teams. We have 3 teams working on it. Not so much, but it's growing. And user-centric approach. The user should be the center in our should be have a good a meaning about our application, how it should looks like. So
Mhm.
there's
Yeah,
also
I think that's important, and that's a general challenge that if you have several teams working on the overarching system, that
yeah,
somehow you need to make sure you have a common look and feel. And as you say, if you have a shared design library or component library, if you have a well-established design system, if you have something like Storybook, all those things help to align the different teams to get a joint, a common look and feel.
yeah. But I showed you the monorepo. You can also use a monorepo, of course. There's also you can share things easier. But
Mhm.
in our real application, we don't use it mono application, not yet. But okay, we want to step
Mhm.
over one, so we can share more things quite easily. But
Mhm.
we're still happy about it. We can, very good.
Awesome.
So so those
Would
are
you do it again?
sorry.
Would
Do it.
you do it again? Would you use this architectural style again?
Oh yeah, of course. Yeah. I'm very glad about it. Also give like you talks about it. So I'm very happy about it. So we are going forward with it, and also with Native Federation. Uh,
Mhm.
it's blazing fast. It is. There's also it's loads Angular once and also shared libraries, and it's caching the shared libraries. It uses ES build under the hood, and native modification also embraces import maps,
Mhm.
framework agnostic, and future proof. So it is very good. So
Awesome.
I'm
Cool.
happy about it. I've no, I don't want to do things differently next time. No.
That's a good message.
Yeah.
Yeah, cool. So big thanks for sharing all of this. This is really an amazing case study. And I think we inspired a lot of people out there to at least think about this architectural style. You know, if you have it in the back of your head, this is enough so that it comes in mind when you should consider it or when you should not consider it. It always depends. But having it in your toolbox makes a lot of sense.
Yeah.
Awesome.
I agree. Yeah.
So thanks. And yeah, see you around.
Yeah. Thank you very much.
Thank you.